All right, so the lesson. Here we go with the new stuff. Combining functions. This time we're going to talk about multiplying. On the next slide, we're going to talk about dividing. Multiplying is a pretty big deal in Algebra 2. We're going to do it this year using the box method. Hopefully your Algebra 1 teacher did it that way as well. That's why I'm choosing to do it. I want to try to remain consistent. All right, so when two things are next to each other, it means multiplying. In this case, we have some terms inside this parentheses, and we've got some terms inside this parentheses, and the quantities that are inside the parentheses are next to each other. That's what tells me we're multiplying. So let me get rid of that writing so it's clear what's written here. The idea is there's two terms inside here. I'm going to write those two terms at the top of this box. So when you're multiplying, because you have two terms, you need two boxes inside this ginormous box. And then there's two terms inside the next one, so I need two boxes going downward. So it's a 2 by 2 box, 2n plus 1. And now the idea is all the terms that line up for each box, so like 2n goes in here and 2n goes here, but then for the next box, 2n is still also lined up with this box, but now it's 3 that's lined up. So we're going to multiply all the numbers, the big numbers, the coefficients, so I guess I should explain that. 2n, in this case, 2 is the big number. That's called the coefficient. And then if you don't see an exponent, you get to assume it's 1. I'm going to call those the little numbers. Otherwise known as the exponents. So when you're multiplying the functions, you're going to multiply the big numbers, the coefficients, but you're going to add the little numbers. You're going to add the exponents. What does that mean? So 2n and 2n, we said were lined up with this box. 2 times 2 multiply the big numbers is 4n. Then you're going to add the little numbers. If you don't see it, the little number's 1, the little number's 1, and that makes 2 altogether. So in this box, 4n squared. Over here, we said 2n is lined up with 3. You're going to multiply the big numbers. 3 times 2 is 6. Well, n to the 1, there are no n's, so it just stays n to the 1. Let me erase some of my nonsense. Multiply the big numbers, add the little numbers. So we said 2n times 2n gives me 4n squared, and 3 times 2n we said was 6n. Well, now 2n is lined up with 1, and 2n times 1 is 2n. 1 and 3 are lined up here. Multiply the big numbers. 1 times 3 is 3. So the answer now for this problem is going to be 4n squared. I'm going to start with the top box, then write the next box, plus 6n, then write the next box, plus 2n, and finally the last box, plus 3. And what you're going to notice, 6n and 2n are like terms. We're going to go ahead and add those together, meaning the answer is 4n squared plus 8n plus 3. Now, I know it says find the domain and range. I'm going to do that for these last two problems. I want you to get used to the box method first before we go back into domain and range. So there's the answer to number 1. Let's erase all this stuff and start over. Uh-oh, the eraser's not working. There we go. Let's take a look at this one. 3p minus 3. So we're going to write that up at the top. Each one gets its own box, and p minus 1 is going to be written downward. Multiply the big numbers, add the little numbers. Remember, this is p to the 1 if you don't see it, and p to the 1. So there's also a 1 out front if you don't see a number there. So 1 times 3, that makes 3. p to the 1 and p to the 1 makes p to the 2. 1p is lined up with negative 3. That would give me negative 3p. Again, 3p times negative 1 is negative 3p, and negative 1 times a negative 3. Well, negative and negative is positive 3. So starting in the top left box, 3p squared is what we've got, minus 3p plus 3. These guys are like terms, meaning the answer is going to be 3p squared minus 6p. Remember, 3 and 3 is 6. And then at the end, plus 3. All right, now we're going to look at the box method again, but we'll go ahead and do the domain and range situation. Let's cover up these old problems, uncover some new ones. Boy, these are similar. 3p plus 3. 3p plus 3. Along the side, 3p plus 2. Multiplying the big numbers 3 and 3, that gives us 9. P to the 1 and p to the 1. Add the little numbers, that is 2. So we got 9p squared in this box. 3p times 3, that's 9p. 3p times 2, positive 6p, and 2 times 3 is positive 6. So we've got 9p squared plus 9p plus 6p plus 6, and 9 and 6 makes 15. So the answer to this problem will be 9p squared plus 15p plus 6. Now again, I want to point out a couple of things. One is that we have to rename this function so I can name it anything I want. W of p, k of p, m of p. And then instead of p, when I go to Desmos, I actually got to change it to an x, because I found out Desmos has no idea what the p means. So it looks like we've got this. I'm going to turn this function on. So notice the p's are now x's, and it creates this shape. It's a parabola. You can move your graph around as needed. See more of that graph. One of the things I notice is look into the left and the right for domain and range. If I trace this to the left, it looks like it's going to go forever. It's never going to stop. So one thing I could do is put an arrow on the left side, and then if I trace this thing to the right, wow, it looks like it's not going to stop again, so it's got an arrow in that direction. Remember, if it doesn't stop in either direction, we get to call that negative infinity to infinity. So the domain for this graph, let me grab my pencil again. And notice it says to do it in set notation. The ones on the right, we're going to do an interval notation. So set means you got to open up your set. Domain is x such that x is between two numbers. In this case, negative infinity to infinity. And there's no lines under the arrows because infinity is not an actual destination or a place you can touch and point out on the graph. Now let's look at the range for this. Does the range do the same thing? Remember, range is how high, how low. So when we started the lesson a couple of days ago, we said how low and how high does it go? Well, how low it goes is, if this is 0, that's 1, 2, 3. Well, it's hard to tell. Let me see if I can touch it. Nope, it's highlighting my... Looks like the lowest point. Ooh, which number do I go with? Well, you want the y value, so we're going to say there. That's the lowest it goes, 2.75, but then how high does it go? Oh, again, it's got these arrows. It doesn't stop. It goes off the graph, so that goes to infinity. So coming back over here, the range is, open that set, y such that y is between two values. It was, I think it was Yeah, 2.75, had to double check. And positive infinity. All right, let's erase that. Let's take a look at this last problem. The biggest thing today is box method. Do you understand how that works? Do you get that you got to put k minus 2 at the top, k minus 3 along the side, k to the 1 and k to the 1 makes k to the 2. Negative 2 and k is negative 2k. Negative 3 and k is negative 3k, and negative 3 and negative 2 is positive 6. These two guys, those are the like terms. They're almost always diagonal and in that place. So the final answer for this one is k squared minus 5k plus 6. All right, let's go graph that, see if we can get a domain and range. This time, because the problem's on the right, I'm going to do it in interval notation. Whoops, wrong place. So again, I had to change the k to an x. Let me turn this graph off, turn this one on. Go get my writing tools. It's the same shape. How far left does it go? It looks like it doesn't stop. It goes off the screen. Negative infinity. How far right does it go? Looks like it doesn't stop. It goes off the screen. Positive infinity. So going back over here, negative infinity to infinity. Put it in parentheses. Remember, instead of writing this, if you didn't want to write it, you could have done this. The R with the line, that means all real numbers, means the same thing. Both of those are the right answer. Now, how high does it go? How low does it go? Again, it's not a perfect point, so I'm going to have to move my marker. How low did it go? Negative 0.25. How high did it go? Again, it went off the screen, so it's going to infinity. So we'll remember that, negative 0.25 to positive infinity. Infinity is not an actual place you can find, so that's parentheses, but negative 0.25 is, so this guy gets a bracket. He's included in the set. All right, here are the last couple problems. We're going to talk dividing. We're not going to talk much about it. We're going to keep it simple for now, and at the end of the school year, we're going to go ahead and talk more about it. The idea is you have g divided by h. We're just going to put g on top, or in this case g of a. So the g function is negative 3a squared minus a over, what was h? H is negative 2a minus 4. That's the answer. That's the way we're going to leave it for now. We're just going to put them where they go, leave it like that. Now, as far as domain and range, I'm sorry, we don't even really want to worry about the domain when we divide. We more so want to worry about the domain. So that's usually going to be what they ask you to do. The domain, I can't even talk. But that's all, folks. The domain is going to be x such that it's going to be all real numbers. Except we got to figure out, usually in the domain when you're dividing, what can you not have? What's excluded? And the exclusionary stuff is going to come from the denominator. What's excluded? Now remember, whenever you have a fraction, you're not allowed to do 1 divided by 0. You cannot have a 0 on the bottom. So what we're going to do is we're going to say whatever's on the bottom, negative 2a minus 4 in this case, cannot equal. So we're going to put a line through the equal sign, and we're going to say it cannot equal 0. And now we're going to solve. We're going to do the opposite of everything we see to see what would cause this to be 0. The opposite of negative 4 is positive 4. Bring the negative 2a down. These cancel out. 0 plus 4 is 4. Remember, two things next to each other means multiply. So the opposite of multiplication is division. I'm going to go ahead and divide by -2 to get the a by itself. The -2's cancel. That leaves us with a cannot be equal to 4 divided by -2 is -2. So the only thing we can't have on the bottom is -2. Whoops, our variable is a, not x. So it can be all the numbers, any number you want, all real numbers, except a is not allowed to be -2 because -2, if it were plugged in, -2 times -2 is +4, and +4 minus 4 would give us 0 on the bottom. All right, so now over here, let's look at this one. We got to put everybody in the place where they go. H divided by G, what was H? 3a is what H is. What goes on the bottom? G, what was G? -a minus 3. So everybody's where they need to be. This is the answer. But now we got to figure out the domain. Whoops. The domain is x such that it can be all the numbers, except what can a not be? Well, we're going to take whatever's at the bottom. It's not allowed to be 0, so -a minus 3 cannot equal 0. The opposite of -3 is adding 3, so we're just solving to get a by itself. So now -a comes down, the 3's cancel. It is not allowed to be 0 plus 3 makes 3. Remember, if you don't see a number, that's -1. So what we want to do is divide by -1, because two things next to each other means multiply. The opposite is divide. Whatever you do to one side, do to the other. So 3 divided by -1. The -1's cancel, leaving us with a not allowed to be equal to -3. And again, that's because if you plugged in -3 here, negative and negative is +3, and 3 minus 3 makes 0, something we're not allowed to have. All right, last but not least, we'll make it a little simpler. G over F of 3, so now we don't even have to find the domain. We just have to put G where it goes, F where it goes. G is 3a plus 2 over, what was F? 2a minus 4. Now the reason we don't have to do domain is because now they want us to plug in 3. So now we're going to put 3 everywhere we see an A. Over 2 times 3 minus 4. We're going to solve the top. 3 times 3 plus 2, that's 11. On the bottom, 2 times 3 is 6, minus 4 is 2. When they ask you to plug in the number, you just want to evaluate it. You try to simplify it to one number if you can. The answer is 11 halves. So go ahead and try part B. See and check for understanding, and I'll help you out if you need help.